right, guys, day 3 is the type of factoring that, to be honest with you, is my favorite because I think it's the fastest, the easiest to recognize. There's no guess and check involved in it. It's just bam, there it is. More students struggle with this than anything else, and I really don't know why. So if you guys can tell me why, I'd appreciate it because I have no idea why. All right, so if I would ask you to factor this, what red flags come up in your mind that there's something wrong with that for everything that we've learned? There's what? There's not another x. How many terms is this? How many terms is everything we factored? 3. Everything we factored has been x squared, x number, right? Could I write this so that's exactly how it looks? Could I write 16x squared plus 0x minus 25? Yeah. Is it still the same thing? Does it look more familiar to you now? Okay. So let's kind of go from there. Let's see what we can do. So is there a GCF? No, nothing goes in all of them. Okay. So we'd set up our parentheses, right? Last one's negative, so what are your signs? They're good. Different, opposite, 1 plus, 1 minus. Bless you. Bless you. Goodness sakes. We're a bunch of sneezing kids today. All right, options for A. Thank you. You guys know I like the ordered list, right? It's a little bit of OCD in me. Drives me crazy if it's not in order. All right, options for C. Good. So write down our options. Do you want to go 1 and 16, 2 and 8, or 4 and 4? 4 and 4? Okay, so 4x and 4x. 1 and 25 or 5 and 5? Do you want to go 5 and 5 or 5 and 5? 5 and 5. You sure? Okay, all right. You guys realize that was a joke, right? All right, and then we got to check, right? So when we check this, the inside, 5 times 4x is 20x. Negative 20x, which cancels, which is exactly what I wanted. All right. For today, we are looking at factoring stuff like this, but I'm going to tell you, you don't have to go through that whole process. Yay, right? Don't have to guess, don't have to check. I can just bam, there it is, and move on. Okay? See if you can figure out how I know all this. The original problem had 2 terms, which is like we've never seen anything with 2 terms yet. What do you notice about both of these numbers? They're both perfect squares. You guys know your perfect squares? Hopefully, at least up to 12 squared, I would hope you would know. Yeah, but 16's perfect square. Is x squared a perfect square? Yeah. And 25 is a perfect square. What do you notice about how these factored? They're the options for A, you ended up just taking its square root. The option for C is its square root. What sign's in between here? Minus, which means these signs are always plus minus, because if last one's negative, they're always plus minus. There's your shortcut. So let's take a look at this on your flow chart. So still GCF's always the first thing we look for, no matter what. But then you have to recognize how many terms you have. Okay? So I need 2 terms for this to work. It's called difference of squares. So if you hear me refer to it as a difference of squares, that's what I'm talking about. They are both perfect squares with a minus sign. Why would I have to have a minus sign? Come back to this. In order for that, because that middle term you want to be nothing, right? How do you get these to cancel out? You have to subtract the same number from itself. You have to have 1 positive and 1 negative. And in order for my signs to be different when I'm factoring, that last one has to be negative. Okay? So if you'd have 2 numbers and there's a plus sign in between, can't do it. All right, so you'd set it up, your parentheses, 1 plus 1 minus, because that last one's negative, and then you just take the square root of each one. That's what fills in. Yeah. Then at this point, if there's no GCF, you can't do anything else with it, you can't do anything. Eventually we'll look at stuff, but not right now. All right, so just again, remind your signs, that last one has to be negative for this to actually factor, so we're going to have opposite signs. And this is like textbook definition, just so you're used to seeing this. A squared minus b squared, so you have 2 perfect squares, and there's going to be subtraction in between, and you're just taking the square root. So if I look down here, which of these expressions can be factored using the difference of squares? So there's 4 of them down here. Which ones follow all the restrictions and requirements we just kind of talked about? First one? Yep. How does this one? How would this one factor? Yeah, x plus 5, x minus 5. Can I factor this one? Why not? Good. 12's not a perfect square. Can't factor that one. Nothing I can do with it. This one? Has to be a minus sign, so I can't do this one. This one? Mm-hmm. How would this one factor? Very nice. Square root of 36x squared is 6x. So that's going to be your option for A. Square root of 1 is 1. Beware of that dreaded 1. It shows up all the time. You're like, oh, I can't do it. Yeah, square root of 1 is just 1. All right, x squared minus 49. Oh, some of you pick up fast. Do you see why these are my favorite? Yeah. When you see 2 terms, minus sign, and they're both perfect squares, you know one's plus, one's minus. Square root of x squared is just x. Square root of 49 is 7. For whatever reason, most students, when they struggle with these, they look at that problem, they're like, oh yeah, they're perfect squares. So they tell me the factored form of it is x plus 7. What should you be able to do with your answer to check it? Multiply it back together. So if you tell me the answer is x plus 7, how do you multiply that to get where you started? You can't. Okay, so kind of keep that in mind whenever you're writing an answer down. How about this one? Oh, be careful. What's a square root of 16? Good. 1 plus, 1 minus, and you're taking the square roots. 25x squared minus 36? So can someone please tell me why people struggle with these? Anybody? Are we doing okay? No, they do. Yeah. Not really going to, I'm going to do a little bit to this, but not much. Yeah. Mhm. As it should. Take a look, guys. So if we go to check these, what's 6 times 5x? 30x. What's 5x times negative 6? So the fact that there's an x on there, does it make a difference? Because it cancels out, goes away. So that middle term is always going to vanish on you. All right, let's take it up one notch. 50x squared minus 18. What's the first thing you're always supposed to look for? What's the GCF? What number divides into both 50 and 18? 2. So take out the 2. So what's 50x squared divided by 2? 25x squared. 18 divided by 2? 9? Not 19. It's Monday. It's early. It's okay. Now is it a difference of squares? Yes, now it is. So how does this factor? Good. Don't forget your baby brother. He's going to tag along with you. Yeah, so when you first glance at it, it's like, that's not perfect. Don't abandon it completely. Make sure you're looking for that perfect square, or that, GCF to go inside there. Yeah. Doesn't matter. As long as one's plus, one's minus, I don't care. All right, 64x squared minus 100. This problem will be the most missed problem on a test. Anybody know why? Why will so many people miss it? There's a GCF in there, but they're perfect squares the way they sit. Yes. Would you leave 2/4 as a fraction? It's the same idea. You wouldn't leave 2/4 as a fraction. You would make a 1/2. You got to simplify. So this throws everyone because they're like, yeah, they're perfect squares. But you can take, yeah, there is. You can take out a 4. What's 64 divided by 4? 16 x squared. 100 divided by 4? 25. Now how does it factor? 4x plus 5, 4x minus 5. And don't forget your baby brother. Now, I do want to talk about this real quick. Most of you probably would have looked at this and went, oh yeah, that's 8x plus 10, 8x minus 10, right? Do you see the common factor sitting inside there? You could have. You could have factored this first and went, oh crap, there's a GCF sitting in there. Take out a 2 from this one and a 2 from this one. 2 and 2 make 4. Okay, if you want to, you can, but to me it's harder. But if nothing else, guys, get in the habit when you're factoring, look at your factors. Is there a GCF sitting in there? Because if there is, you've got to take it out. Okay, otherwise you're going to lose a point for that. All right, last one. 12x squared minus 75. GCF? 3. Good. 4x squared minus 25. Is it a difference of squares? Are they both perfect? Is 4 perfect? Is 25 perfect? Yeah, okay. How does this factor then? Good. And don't forget the 3. I got another slide, don't I? That's on my next slide, I think. Yes. 121x squared minus 144. I would expect you to recognize your difference of your squares up to 12 squared. That's 11 and 12, yeah. So square root of this is 11, square root here is 12. So how's the factor? 11 what? 11x? A lot of people forget it. I just want to make sure we're not losing it. X squared plus 100? Good. Can't do it. There's plus sign there, so it's not factorable. Yeah, it's a trick. You guys be careful of those. If you see that plus sign, it's like a big old stop sign. You can't do that with 2 terms. It's got to be minus. 4x squared minus 75. 75 is not perfect. So what do I do? Nothing. I can't do it. It's not factorable. It looks like it would be, but that 75 is a problem. All right. Difference of squares. Real fast. We hit it. How are we feeling? Like those? You haven't been here in a couple days and you never watched a video. That'd be why.